Here is another fascinating property: covalent compounds, which are more likely to dissolve in non-polar solvents like oil rather than water. This is because likes dissolves to likes. Non-polar molecules dissolve in non-polar solvents. A good example is wax, which is a covalent compound. It won't dissolve in water, but if you try dissolving it in a non-polar solvent like oil, it breaks down easily. Many covalent compounds are soft and flexible because the bonds between the molecules aren't as strong as ionic or metallic bonds. This makes covalent compounds more flexible and easier to shape. Think of plastic, a common covalent compound. You can bend, twist, and shape plastic easily because the covalent bonds holding it together don't create a rigid structure. However, not all covalent compounds are soft. There's an important exception: diamond. Diamond. In diamonds, each carbon atom is bonded to 4 other carbon atoms in a giant covalent structure, making it incredibly hard. Diamonds are one of the hardest natural substances on Earth. This is because of their strong repeating network of covalent bonds, which gives them their extreme durability. So, what other materials do you think might form a giant covalent structures like diamonds? Share your guesses in the comment section. Covalent bonds can vary in strength. Single bonds are weaker than double bonds, and triple bonds are the strongest. This bond strength can affect the overall stability and reactivity of the compound. For example, hydrogen gas, which we all know as H2. Hydrogen gas is held together by a single bond, which is relatively weak. Next is oxygen gas. Oxygen gas form a double bond which is stronger than single bond than that of hydrogen. Next, we also have nitrogen gas. Nitrogen gas contains a triple bond, making it one of the most stable and unreactive molecules. Can you think of any other examples of molecules with double or triple bonds? That's for you to answer. Covalent compounds usually have a non-crystalline structure. Their molecules are packed together without a regular pattern, which contributes to their softness and low melting point. Let's take a look at sugar again, for example. It doesn't have a regular repeating structure like salt does because it is made of individual covalent molecules. So let's recap what we've learned about the properties of covalent bonds. Covalent compounds usually have low melting and boiling point. I also mentioned that they are poor conductors of electricity. They also dissolve better in non-polar solvents. Covalent compounds are often soft and flexible, with diamond being a major exception due to its giant structure. Covalent bonds can vary in strength from single to triple bonds. Let's take a quick quiz. Which of the following is not a property of covalent compounds? High melting point, poor electrical conductivity, or solubility in non-polar solvents? Thanks for joining me on today's lesson on the properties of covalent bonds. From melting sugar to the sparkle of diamonds, covalent bonds shape much of what we see in the world around us. See you next time. Bye.